Pleasant greetings, everyone. Good evening. Good evening, everyone.
Evening, sir.
Good evening, sir.
Good evening, sir.
Wonderful, wonderful. Nice to meet everybody. I hope you all enjoyed the little break that you got. It wasn't really much of a break, just maybe like a day because we didn't have class on Wednesday. But we're back at it again, and we're fast approaching the end of February. Can you believe it's the year just started and we're right here again? But we are officially 2 months, a few days. We're basically 2 months and 1 week away from the day of that exam. So we're 2 months and a week or so away from the exam. All right, there are a couple of announcements that I have for you. All right. I know that some of you may have been reaching out to me. I lost my iPhone. Well, not lost it. I misplaced it somewhere, but I think I know where it is. So if any of you may have reached out to me during the course of the break or regarding SBs or stuff like that, I'm trying to get access to it so as soon as I can. But like I said, guys, if you guys can physically bring something to me at the school, you get a faster response than over the phone. All right. In regards to that, now the deadline for the SB is mid-March. I've been telling persons the 15th, but I'm not quite sure which day is the 15th. But anywhere around mid-March is when the submission of the SB should be done. Now, should you submit an SB that requires any additional corrections, then I'll be sure to give it back to you during the process of me marking. But if you submit and it look good, I won't give you back the SB. I'll just give you the grade that you desire. All right. And my pass mark is 16. So if nobody no reach over 16, I'm gonna give you back the SB and make the necessary adjustments or stuff. So wherever you are in the SB, however far you are, most of you should be at the analysis by now because that was the last thing I uploaded in the Google Classroom. So you guys should be somewhere there or thereabout, or you should be wrapping up your graphs or somewhere there or thereabout. So you still have another 3 weeks or so left. So you have time. All right. So we want to jump on that as soon as possible. All right. So we can get that out of the way so you guys can get into focus mode because mid-March would mean that you only have a month or you only have 7 weeks before the exam. So you need all that time where you're not focusing on anything apart from just reviewing. All right. Now, missing a class is going forward for the rest of the next 2 months. Missing a class is not something you want to do right now because we have a few topics left to cover, and um, even though the recordings are there, recordings are not always the most ideal way of learning. Not everybody learns from recordings. It's good to have it, but it's not always the best tool. I can tell you that for certain because I have a class at NCU that I'm doing, and because I can't attend physically, I have to watch the recordings, and sometimes I'm bored. So, sometimes being in the live class is a lot better than having to watch the recordings. Nevertheless, try to jump on that and let's wrap this up, guys, and get that SB out of the way. Now, the next thing is that promotions for our marathons. Sure that you guys, some of you may be familiar with what our marathons are. Right? So marathons are more extended version. Currently, we have a few students that are attending my Saturday classes that I'm doing for only $500, just as a form of recap of old concept start. But the marathons are going to be a longer version for the class. I don't have all the details as yet, but I can tell you that the marathons usually starts the very first Saturday in April. The very first Saturday, right? We may even start it the first Saturday in the last week of March. But let us see. But for now, marathons are scheduled to start in April. I want you guys to prep up for that. What I like about this year's marathon is one, usually we do a Saturday Sunday, right? We do a Saturday Sunday, but the Sundays usually don't have very good turnouts. We'll get like maybe like 13, 14 persons because of where they live and stuff like that. Some persons cannot come on a Saturday because they're 7 day or they work. So Sunday is your only option. So what we have done this year is that we have made the marathons online for Sunday. That means there's no reason for you to miss it. So it's still going to be the same 5 hours. We'll be online, working straight, working through past paper questions from, let's say, 11 o'clock in the morning until 5 o'clock in the evening, straight online, full marathon. So you have that option if you're not able to attend face to face, or you can just join face to face. It's up to you. The face to face will be on Saturdays. The online will be on Sundays. The approximate cost is going to be it's not going to be more than 2,500, but it's not going to be less than 1,500. So prepare yourself for a cost to be posted anywhere within that range. Remember, it is 5 hours of teaching. Majority of the places you go, you'll find them charging you $2,000 per hour. I don't know how that makes sense, but they're doing their thing. So Miss Morgan usually charges anywhere between $2,000 for the whole entire 5 hours. No man, the cost is not that bad. Like I said, you can run a survey and just go to some other institutions. They'll tell you. I'm currently working at the Czec College, right? I go to the Czec College on a Saturday mornings, and it's $2,000 they charge the students there for 2 hours. We're charging you guys $2,000 for 5 to 6 hours. So do the maths. Pretty much, if you do the maths and you divide the 2,000 by 5 hours, then you realize that we're charging you $400 per hour. Pretty much. So we're not killing them. All right. All right. So with that said, I just want to prep you from now. A post will be made, and you guys will be able to see. You guys will be able to see all the details. We have package prices as well, right? So if you invite a friend, we can take off $1,000 off your amount. Sometimes it depends on if you invite persons from outside to attend, you can end up come on the marathon all free. So it just depends. So we're gonna put together a nice little package that you guys can choose from. Some person will choose to want to pay per day or per marathon. Some will want to do like a whole package payment. It's up to you. So we're gonna try to make it affordable for everybody. Okay. All right. But as time draws near, I will update you and give you more information going forward. All right. So those are the only two announcements I have for you. We're gonna pick up from where we left off last week, Monday. Remember, guys, everybody is welcome. It's not a MI thing. It's a mathematics marathon. So if you know somebody, we know somebody, we know somebody, we are struggle and they need the help. Remember, it's a complete year academic review marathon. So we are run back through everything from when I started teaching in September all the way up to the day or the day before the exam. But we're going to be covering those topics using the actual exam questions. All right. So saddle up for that. In the meantime, in between time, go and take advantage of the little 500 ones that we have on Saturdays. Because they want to cheap in on them effective. So you can take use of them 500 one because them so stop. You have a couple more of those left. I'm gonna stop them in mid March so that you guys can get a little breathing space. So after mid March, no more Saturday 500 classes, and then we're gonna jump into the marathons. All right, we want to really start exercising and getting ourselves prepped for that exam on May the 6th. Okay. All right. So now I'll take up too much of the class time talking about anything extracurricular activities. We're gonna jump into what our objective is going to be for this class today. Now, in our last class, I believe that we would have. Oh, pardon me. Are there any questions or any comments? You can leave it in the chat, and I'll be sure to respond to you. So when would be the marathon? Oh, it would start in April, Antonella. Yeah, it would start in April. All right, very first Saturday. So the Sunday ones will be online, and the Saturday one will be face to face. Remember that the Saturday marathon is different from the Sunday one. Okay, it's not the same questions. They are different papers. Okay. All right. And I might just even make for the persons who come on a Saturday, I might just make you come to the one on a Sunday for half or three-quarter the price, just in case you want that extra. So me I'll put together something nice for you, so you can take full advantage. All right. Okay. All right. Good. So, in our last class, we would have wrapped up. Was it algebra that we were on? Confirm that, please.
Yes, sir.
And we would have done simultaneous equation.
Yes, sir.
Good. So we would have went through all those examples and stuff. We're gonna do one more example for tonight, and then that's it. No more algebra. We're moving on to a new topic tonight. What is it that we do on Wednesdays, guys? Transformation. Are we currently doing transformation at the moment? Rotation, reflection. Is that what we're doing on Wednesdays now?
Yes, sir.
Yes,
All right.
sir.
So tonight, after the recap example of simultaneous equation, we're going to be starting trigonometry tonight. Okay. All right. So one recap question. Thank you, Galia. So one recap question. Let me grab my textbook. And so last week we would have covered simultaneous equation. For those who were not able to join that class or be a part of that class, I've already posted the recording from last week. So you can always access that at a time convenient to you. Okay. So one example to just wrap up. Finally, we've been on algebra for maybe like about 2.5 months now. So finally we come to the end of that. And it's time. Okay. All right, we're gonna do 2 examples, right? I don't want to rush it enough. So we're gonna do one. Oops, I'm so sorry. My whiteboard is gone, guys. Oops. Okay, my bad. Are you guys seeing back my whiteboard now?
Yes, sir.
Lovely. Thank you. Okay, so we're gonna do one worded example and one example where the equation is given to you. Okay. Give me a second. All right, so here's the worded question, guys. I'm gonna dictate the information to you, and then we can have a look at it. Okay. Mhm. Going on here. Okay. All right. So for a worded problem now, let's see. Okay, worded problem simultaneous equations. All right, here we go, guys. Take this question down for me. Ria, that is RIA. Ria or Raya bought 3 hot dogs and 5 hamburgers. Ria bought 3 hot dogs and 5 hamburgers for $32.75. Ria bought 3 hot dogs and 5 hamburgers for $32.75. That's 32.75. Full stop. If Ria had bought 4 hot dogs, if Ria had bought 4 hot dogs and 4 hamburgers, if Ria had bought 4 hot dogs and 4 hamburgers, she would have paid $29. She would have paid $29. Full stop. Calculate the price Rhea paid for one hot dog and one hamburger. Calculate the cost that Rhea paid for one hot dog and one hamburger. Okay? So usually that's what the question sounds like. Not saying that all the time it's gonna sound like that, but majority of the time when you hear a question of this nature, it usually is simultaneous related, right?
Repeat.
We're talking about. Pardon me.
Can you repeat the last part where they say calculate the price?
Calculate the price Rhea paid for one hot dog and one hamburger. All right, so once you hear this question of this nature, right, remember simultaneous equation comes in many, many different forms. But experience alone is going to allow you to have an idea of what these sounds like. But I'm just giving you the traditional ones, okay? So to solve this question, we're going to quickly go ahead then and set up an equation. You can do it however you want. I don't know if you want to let H represent hot dog and, or I don't know how you want to do it. If you want to let A represent hot dog and B represent hamburger or X, whatever. But in this case, I'm going to keep it straight simple. I'm going to say let X equals hot dog. And I'm going to also say Y. I'm going to let Y equals hamburger. All right. I'm used to X and Y, so I'm going to keep it like that. So for me, X represents hot dogs and Y represents hamburgers. All right. Now, the first scenario that was created was that 3 hot dogs, that means 3X, along with 5 hamburgers, that's 5Y, will cost $32.75. That becomes equation 1. All right. And it says that if Rhea had bought instead 4 hot dogs and 4 hamburgers, she would have paid $29. That's equation 2. All right. So believe it or not, ladies and gentlemen, to write that equation, CXC gives you 2 points. Believe it or not, I'm telling you. They give you 2 points just to read, interpret, and write down the equations. All right. Now, just like last week's class, we're going to go through the process. We went through about 3 examples. So we're going to do that right now. We have equation 1 and equation 2. Remember the objective and our decision have already been made that we're always going to try to eliminate the middle. So I'm going to go ahead. I'm going to multiply up here by 4 and down here by 5. All right. And for those of you who are wondering where the 4 and the 5 comes from, as we discussed last week, that the numbers that I'm choosing to multiply by are numbers that are already in the equation. So notice that I'm trying to get these 2 terms to become the same. So that's why I chose to multiply the top equation by 4 and multiply the bottom equation by 5. Hopefully you recall that step. Let's proceed to go ahead and do just that. So we're going to multiply the whole entire equation by 4. 4 times 3x is going to give us 12x. 4 times 5y is going to give us 20y. And 4 times 32.75. Can somebody help me out with that? 4 times 32, that sounds like 128. And 4 times 3/4, that's going to be 3. That's 131. Can you confirm? Can you confirm if 4 times 32.75 is equal to 131?
Yes, sir.
Thank you very much. Proceeding, 5 times 4x, that's going to give us 12x. Sorry, whoops, 5 times 4x, that's going to give us 20x. Focus, Mr. Peart. 5 times 4y is going to give us 20y. And 5 times 29, that's going to give us 145. Can somebody confirm, please?
Yes, sir.
Thank you very much. All right. Now, if you notice that after doing that calculation, notice that the terms in the middle are now the same. So we can easily cancel them by subtracting. Remember that we said last week that if the signs are the what? Same, we're going to subtract. So by subtracting 12 minus 20, that's going to give us negative 8x. 20 minus 20, that's going to give us 0. That was exactly what we wanted to do. And 131 minus 145, that sounds like it's going to be approximately negative 14. All right. And if we go ahead then and divide both sides by 8, which we have gone through multiple times, negative 14 divided by, sorry. So negative 14 divided by negative 8. We have to get a positive answer because the money we are dealing with. So based on this here, I should get 6 over 8, which is 0.75. So that's going to be, is this 1.75?
Yes, sir.
Very good. So that's $1.75. So if X is equal to $1.75, that means one hot dog was worth $1.75. All right. Now, final step, we're going to go ahead and we're going to substitute. We're going to substitute 1.75 for, Oriana, your cursor is in the way, thank you. So $1.75 for X. And you're going to choose either equation 1 or 2. So I'm not going to choose equation 1 because I'm going to have to deal with this decimal and I don't want to deal with that decimal. So I'm going to choose equation 2. All right. Because I don't have to deal with any decimal. So anywhere I see X, I'm going to put 1.75. So that's going to be 4 times 1.75. Then we're going to have plus 4y. And that will work out nicely to be equal to 29. All right, so 4.1.75, that's going to be 3 plus 4, that's 7. Can you confirm that, please?
Yes, sir.
4y equals 29. We can simply carry, Nathaniel, your cursor is in the way. Thank you. Carry over the 7 here. We're going to have 4y equals 29 minus 7. So 4y is equal to 22. So y then is equal to 22 divided by 4. We've gone through this whole equation thing, so you guys should be here with me. 29 minus 7 is 22. 22 divided by 4, that's going to give us 5.5. So $5.50. Am I off or am I right?
You're correct.
$5.50. Thank you. All right. So mathematically working out that one hot dog is $1.75 and one hamburger is $5.50. All right. So that is how you solve a worded problem. And like I said, there's plenty of them. Plenty of them. Right? But we will have the time and the experience to go through these things. All right. Simultaneous equation is worth 3 points on the exam. I don't feel like it's a question that you guys should dash. But, just take some practicing. That's all it takes. Okay. All right. Any questions on that? Guys, as we move into the last.
No, sir.
No question. As we move, thank you. As we move into the last 2 months of the exam, not only, remember, it's a very intense period of the year, so we can't spend time re-emphasizing stuff that we've been through multiple times. So when it comes to equations, remember, we spend 2 classes on equations, we spend 2 classes on quadratic, we spend 2 classes on simultaneous. So you see certain concepts, I kind of expect you to either know it, or if you don't know it, you should be able to at least be able to follow me as I go along. So we have to speed up the process because we're into the last 2 months. And I usually never have I ever sent a student in an exam to do a paper and you're not able to. I don't want you to go into the exam and say, I've never seen this before. You must be able to see it and say, you know what? Well, I'm going to remember how to do it. But you're not supposed to come out of the exam and be like, Mr. Pierre, never teach me this. We know, no, that's not me. Never have and never will be. So certain things I have to press gas on. I can't emphasize on stuff like PEMDAS and fractions and decimals. When we see them something, we have to run through them quick and fast. Okay? All right. So here's an example of a question where you're not required to write the equation. The equation was given to you already. All right. So here's an example. Solve the equation. Oops, sorry. Pardon me, guys. So solve the equation. Solve the equation. We have 2x minus 5y equals 3. And then we have x minus 3y equal 1. So that's equation 1 and that is equation 2. Okay? Lovely. So once again, as I told you guys, the numbers I'm going to put right here, I didn't grab them out of thin air. I didn't just come up, I didn't just pick them up and just write them down because I just like these numbers. No, these numbers are coming from the terms that I'm trying to eliminate. Remember, I told you can experiment and try to eliminate the x if you want to. But then you have to go remember extra stuff that you don't need to. So stay focused, guys, and just use the numbers in the middle. Okay? Alright, I wanted this to be a plus and a minus now, but it's alright. It's okay. So here I'm going to multiply up here by 3. I'm going to multiply down here by 5. So you know that. Because see, I'm pointing the arrows, guys. See the arrows? The arrows that I'm pointing at, those are the numbers I'm using. So the number 5 that's at the top, I'm multiplying the equation at the bottom by that number. And multiplying the top one by 3. I know that some of you might be asking, then, so what about the minus sign? I ignore the signs because I know what the rule is when the signs are the same and when the signs are different. So that's why you don't see me use the minus 3. All right? But if you use the minus 3, it won't make a difference. It won't make a difference at all. All right, let's go. Go ahead and multiply everything by 3. 3 times 2x is going to give us 6x. 3 times 5y is going to give us 15y. And 3 times 3 is going to give us 9. That's equation 3. Okay. 5 times x is 5x. 5 times 3y is 15y. And 5 times 1 is 5. That's equation 4. And as you can see, successfully we are able to get these two numbers in turn to be the same. So we can cancel them out from now. But what did we do to cancel them out? The signs are what? The same, so we subtract to eliminate. If the signs were different, we would add. Alright? Alright, and this is very straightforward. 6x minus 5x is x. And 9 minus 5 is 4. Look how easy. X is equal to 4. So sometimes it comes out like that. Okay? Alright, so now we're going to go ahead and we're going to substitute. I like to write shorthand, guys. Most of us math teachers, we don't like to write. So we're going to go ahead and we're going to say, we're going to sub 4x in equation. We're going to sub 4 for x. Oops, what's going on here? So we're going to sub 4 for x. Sub 4 for x in equation. I'm going to use 1. Equation 2. Straightforward. No challenge there. So anywhere I see x, I'm going to put a 4. There's an x right here, so I'm going to put a 4. 4. Simonia, your cursor is in the way, love. Thank you. 4 minus 3y is equal to 1. Remember, I just substituted the 4 for the x. That's the x right here. So I'm going to go ahead and bring this 4 over to that side. That's minus 3y equals 1, take away 4. So you get take away, because remember that the 4 is positive. Once I brought it over, it becomes negative. Okay? So that's negative 3y. That's equal to negative 3. and y is equal to negative 3 divided by negative 3 works so that y is equal to 1. Alright? Guys, when you're getting these questions, you see, once you start get some nasty looking funny number, just know you do something wrong. Right? Because when we give you these questions, we're not giving it to make your life difficult. We're giving the questions so that the numbers can come out nice. You look at the previous example I did. Even though I got decimals, you notice I didn't get anything too funny. I never get something like 1.672 or 5.398. No, we get numbers like 1.75 and 5.50. Easy numbers, nice numbers. So there's no say when you're working these questions out, if you're not getting a flow and the answers aren't popping out easy, you did something wrong. Okay? All right, any questions on that?
Sir,
Mm-hmm.
there's, all right, I'm a bit worse. All right, so we have negative 3 divided by 3. I thought it would have been negative 1. 3 to itself one time. So
Oh no, we have negative 3 divided by negative 3.
Oh, I didn't say the negative 3 there.
Oh, my bad. It got blending with the division bar sign.
All right, thank you. All
right. Okay.
Sir?
Yes, go ahead.
For the beginning of the equation that you worked, if it's a case where the signs are not the same, do we add instead of subtracting?
That is correct.
Okay, thank you.
Lovely. All right. So that brings us to the end of algebra and the end of simultaneous equation in its entirety. You will see many of these questions popping up in our extra classes and our marathons and on my YouTube channel. You see these questions again and again. But the good thing is that you're not completely it's not a case where you're unaware of what this thing is or how it's done. It just needs some practicing and you'll be okay. All right? All right, that's the end of algebra. So tonight you're going to be introducing the danger topic. The topic that a lot of persons do not like. And that topic is going to be trigonometry. Trigonometry. All right? Now, every year that I teach this topic, people say, oh, sir, I can't be bothered. Me not like sine and cos and tan and sir, it's just hard and me not understand it. And every year I hear the same story. So if you're going to tell me that story, I already know what you're gonna say. My job is to make it as easy as I possibly can. All right? Now, trigonometry. What is this topic about? Now, we're gonna lay out a little map, right? Because what happens is when we learn about a topic, a teacher just comes to class and they just tell us, okay, this is the topic we're doing. And there's no connection, right? So we want to create like a little map. We want to know where we're going, how we're gonna get there, and how are the pieces of the puzzles connected. All right. Now, for me, trigonometry. What is this topic about? I feel like a lot of persons don't know what algebra is about. They just know that algebra is about x and y. That's their very limited knowledge of what algebra is. When I ask them what is functions and relations, so it's about graph. When I ask them what is matrices about, sir, it's something with some numbers now on bracket. So people generally just don't know what the topic is about. They don't know what to expect. And when they don't know what to expect, everything that I teach feels like a bomb. It's like a bombshell. So we're going to lay out a little map when it comes to trigonometry. All right? Now, what is this topic about? What are you expecting to learn at the end of this topic? Here's the map. First thing you need to understand is that trigonometry is the branch of mathematics that governs this particular shape. The triangle. And it's kind of like a giveaway because if you look at it, trigonometry, the first three letters is tri. And there's only one shape that has the prefix tri, and that is the triangle, right? So technically, trigonometry is all about the triangle. But Is it just about the triangle, sir? Do you have many triangles? You've taught us stuff about triangles. I've taught you about the area of triangles. I've taught you about Heron's formula, half base times height, A times B times the sine of the angle. I've mentioned stuff to you about the triangle. I've told you that the types of triangles are isosceles, scalene, equilateral, right angle triangle. So I've given you a little bit of a gist. You know, you've heard the concept triangles before. But for triangles, our primary focus will be on these two things. We'll be focusing on the length of unknown sides. So that's the primary focus, guys. The length of unknown sides. And our next focus is going to be also on the size of unknown angles. So if you notice the two keywords that I mentioned in my writing, size of unknown angles, I'm going to underline the two keywords here. So what I mentioned was the length of what? See that? Two keywords, angles and unknown sides. So our focus will always be centered around these two things. The size of angles, how to find the size of an angle, and also how to find the length of an unknown side. Now, with trigonometry, it's a very broad topic. It's a very broad but a very condensed topic. What do you mean by broad and condensed? Because as broad as the topic is, everything is related to four formulas. Four formulas, right? And these four formulas are, let me grab a different color ink here for you. Here are the formulas that we're going to be focusing on. Underneath the triangle, these are the four formulas that will play an important role in your calculation. So the formulas are going to be one, the Pythagoras theorem. And let me just try to write it a bit clearer. Handwriting's a bit atrocious. So the Pythagoras, this is PY, guys. So the Pythagoras theorem. I'm not even going to go into the whole idea of who is Pythagoras and where he come from and how he invent and why he invented. I'm just going to give you the formula. I'm really supposed to teach it that way, but it's a crash course. So, you're not going to learn everything that you really need to know. You're just going to learn what is important for an exam. So the Pythagoras theorem is the first formula you're going to be exposed to. What is that formula and how you use it? The next formulas are going to be what is called the trig ratios. Obviously, we're not going to learn them in one class. All right, the trig ratios. Some of you guys know it from high school as sine, cosine, and tangent. All right. And then what I'm going to do is that I'm going to take a little box here. Watch this now. So I'm going to take this down. I'm going to put these into a little box. So why are you putting them in a box? Because they work together. One is, the both of them work in the same department. They're not mix and mingle. If it's not one, it's the other one. So both of these guys work in one department. One department. They work hand in hand together. So you have the Pythagoras theorem and then you have the trig ratios. They both serve the same purpose, right? But here's where they both work together in one department. And the department that they work in is the department of the right angle triangle. So these two guys, they are the formulas that is related to the right angle triangle. The right angled triangle. Sir, right angle triangle? I don't remember what that is. Okay, let me just remind you. The right angle triangle is this shape here. It's that shape. And we're going to emphasize on it more. So the right angle triangle is that shape. So these two formulas are the formulas that is related or that will help you to answer questions that surrounds this particular shape right here. All right. So the Pythagoras theorem will either help you to find the length of a side, or the trig ratio will help you to find the size of an angle or the length of a side as well. We're going to go into depth, in details about what that is. All right. So that's the department. Now remember, we said that there are 4 set of formulas, The Pythagoras theorem and the trig ratios are 2 of the 4. So, sir, what are the other 2? Okay, let me just go through the other 2 then. Remember, we're laying out a map, guys. So this is the map that will guide us. So the next set of formulas that we're going to be working with now are going to be the formulas known as the cosine rule and the sine rule. You see, both of these guys, them work in one department by themselves as well. So once again, I'm going to grab a little box here. I'm going to put these guys now in their own little category. They work together. So, so what compartmentalize the formulas? Because them 2 guys, watch me now, it's them 2 people here, them not like each other. You get what I'm saying? They don't like each other. And it's not that they don't like each other. Them not working in the same department. Like you're working in the same building with somebody, but that person is in accounting and you're in administration. The person who works in administration cannot help anybody who works in accounting. And who works in accounting has nothing to do with the person who works in administration. It's the same company, but they have 2 different responsibilities. So the responsibility that Pythagoras and the trig ratio have is not the same responsibility that cosine and sine will have. The job descriptions are different. So the job descriptions are different. We need to know which shape does the cosine and the sine rule work with. And so here it is. The cosine and the sine rule, it works with this shape here. Non-right angle triangle. Sir, non-right angle triangle? I don't understand what you mean by that. It's going to be a shape that doesn't look like this one. Simple. So obviously it's going to be a shape like, potentially we're going to have a shape like the scalene. So this is when now the scalene triangle comes into play. So the scalene and the isosceles. I won't even go ahead and say the equilateral, because the equilateral triangle, there's not really much you can do with that triangle because all the sides are equal and all the angles are equal. So majority of the time, the diagrams that you work with are going to be scalene, not even so much the isosceles, The isosceles can be used now, but rarely will you ever have to deal with the isosceles when you're doing trig. Most of the time, it's always going to be the scalene triangle. All right, so these 2 guys work on the scalene triangle. I'm going to put isosceles there, but definitely not the equilateral. Okay? All right, lovely. Now, here is where it gets interesting now. So we're going to go to a different... So notice now that I have picked off the 4 formulas. 1, 2, 3, 4. That is what trig is centered around, All these years you're hearing that trig is hard and difficult. Really and truly, it boils down to these 4 guys. And understanding how these 2 guys are applied to various questions. Now, here's where it gets interesting now. And here's where I lose a lot of students. This is where now you find students will walk around and spread propaganda about trigonometry and say that trig is hard. Is when they get to a topic known as bearings. Sure that you guys are familiar with that topic. Some of you guys are very familiar because you would have been in other math classes before this one. And then in that math class, you would have heard the teacher talk about, bearings. So here is now where you're going to mention this topic now. So we're going to draw one little line right also, right? And then you have this topic now is called bearings. Okay? And under the topic of bearings, fun fact is that there is no more formulas to learn. Bearings is an application of the 4 formulas. So it's an application of the things you have learned thus far. Application. So this is the part of Trig now where you're gonna apply. Having done maybe between us, we're gonna do at least 25 to 30 questions together using Pythagoras theorem, cosine rule, sine rule, and trig ratios. By the next 3 classes or so, you and I would have gone through various types of questions to get to this point. You will never understand anything that goes on in bearings if you haven't comprehensively grasped the concepts surrounding sine and cosine rule. So bearings is the application aspect of trigonometry. I wouldn't even call it trigonometry, but them say it is because it's the application. And majority of the time, it is going to be where you have to make a decision as it relates to, do I use Pythagoras, cosine, sine rule, or cosine rule. This is the department now. Like when like at the end of the year when you work for a company and you have this employee of the year. Yeah, we're all of the employees from all the different different subsectors or sub companies come together in one big area. You're meeting somebody who works over there and work in that country and that country. Yes. So when you get to bearings now is where sine rule start to be like, oh, hello, Pythagoras, nice to meet you. Cosine says, hi, trig ratios, nice to meet you. And then everybody start to say hello to everybody, everybody bougie, because really and truly, cosine and sine rule, they're in a class by themselves. Pythagoras and trig ratio be like, oh, we don't talk to those persons over there. We don't know them. They don't work in our department. So here's now everybody have to go work together, because now, depending on the question, cosine might need the help of Pythagoras. Sine rule might need the help of the ratio. They might have to work together. And that's the department of bearings. So this is what we call the conference. This is where all of the formulas now come into one area now, and everybody go show up them skills. That person need that person to help that person to get to that formula. All right? So that is the overview of trigonometry in layman's language, or in my language. Right? Just to cut everything short and spicy for you. All right? So let me zoom out and you see. So you can see it looks all over the place, and it's very broad in terms of the amount of things that you need to learn, but it's really condensed, because really and truly everything boils down back to what is in purple: Pythagoras theorem, trig ratio, cosine rule, and sine rule. All right? Any questions thus far on the mapping?
No, sir.
No questions on the mapping, guys? Everybody good to go before we move on? Oh, the question. Oh, Latisha, the question you had. I think you had sent me a question, but I was on vacation at the time. So when I saw it, I was like, I'm gonna respond when I get the chance. But I completely overlooked you. My bad, Latisha. But you got the answer now.
Yes, sir.
Lovely. All right. Are there any questions on the mapping before we get into the nitty-gritty of this now? All right. Everybody look like them good to go. You can use the chat, How can I love this topic, sir? You're gonna see. You wanna make a bet? I bet you that after the first 2 formulas, and I explain it, you're gonna be like, sir, it's not as bad as I thought it was. Wanna make a bet, Miss Grayson? You sure you have money to lose? Oh, so it's a bet. All right. So after Pythagoras theorem and trig ratios, I'm gonna then address you in the class. That's sometime next week. I'm gonna be like, Miss Grayson, how do you feel now? Is it as hard as you're gonna think it? And you probably go on and try win the bet now, but you're not gonna win that bet. All right, you're not gonna win that bet. All right, let's go. So no questions. Let's move right into the nitty gritty. Oh, Mr. P, what are you doing? All right, lovely. All right, so the bet is on, Miss Grayson. I might lose you when I complete everybody, but I won't lose you for the first two. I'm going to make the first two very enjoyable to learn. All right. Okay, here we go. All right, ladies and gentlemen. So we're going to dive into this thing called the triangle. So before I even get into the formula, most importantly, guys, is that we need to understand this guy here. Right? But here's the problem, The problem is understanding this person here. This guy here. Right? This right angle triangle. So we'll size him up. All right. Now look at that. Such a handsome shape. Huh? Such a handsome shape. But people don't understand him. People don't understand this shape. And when they don't understand this shape, like when somebody misunderstand you, them judge you wrongfully, they think you're going to harm them, and you're not going to harm them. You're just an innocent looking triangle. It's like, hello. It's like, hello. My name is Right Angle Triangle, and I'm going to teach you how to solve me. It's very harmless. It's a harmless little triangle. All it has is what? 3 little sides and what? 190-degree angle. And because nobody really understands the triangle, this triangle is highly misunderstood. Let us see if we can give it a chance. Let's open our brains and see if we can understand something about this triangle. Now, very first thing about this triangle is one. It's a very unique triangle, in fact, right? And it's the most important one because every other triangle stems from this guy here. Now, the first thing I want you to remember about this triangle is this side right here. Hold on there. I can use a red arrow. Hold on, guys. Hold on there. So the first thing I want you to do is to remember this guy right here. Boom. Is that side here, so? With the arrow is pointing towards the side here? Oh, sorry. So you see this triangle right here, so? Right? That the side here? I want you to understand what that side is. That side is called your hypotenuse. So this side is called your HYP T Oh, Mr. Piet, learn how to spell. HY hypotenuse. So the hypotenuse, all right? Or we just call it the hype side, or some students will shorten it and say side H, all right? And mathematically speaking, when you do your calculation, you will eventually learn that it is actually the longest side of the triangle. It always works out to be the longest side in terms of the length, all right? Now, here's what I don't want you to do, right? I don't want you to say that it looked like the longest side. No, don't say that. That doesn't make sense, right? Because something can look like and it isn't. It is the longest side when the calculation is completed, but you can't just look at a shape and just assume that that side looks like it's the longest. No, because majority of the time, shapes are not drawn to scale. So yes, it is the longest side in terms of dimensions, but please, for the future reference, do not look at a right angle triangle and just assume that that side is the longest. All right? Now, not question. How do I, or how am I able to identify the hypotenuse side anywhere, anytime on a right angle triangle? If you notice where I'm pointing it from, notice what I'm pointing to and where I'm pointing it from. I'm pointing the hypotenuse from the box that is, correct, Galia. It is opposite to the angle. Oh, no. Hold on, Galia. We take back that. We take back my compliment. No. It is opposite to the 90-degree angle. So I have to take back that. I'm sorry. So the hypotenuse is the side that is opposite to the 90-degree angle. So notice that my arrow is pointing from where? this 90 degree right here. Notice that's where it's pointing from. So anywhere, anytime that you see this figure, you'll be able to identify the hypotenuse side simply because the hypotenuse side is the side that is in front of the 90 degree angle. Now here's where you come in now, Galia. I'm going to place an angle here. And I'm going to call this angle theta. Sir, what is theta? It's just a Greek symbol that we use to represent an unknown angle. Because trigonometry was invented, or the mastering of trigonometry was mastered by the Greeks. Yeah, man. The people in Israel, Jerusalem. Yeah, man. Yeah, man. Them people. So the Greek symbol theta, right here, Theta. I hope that's it spelled. I think so. Somebody can look it up for me, please. Look up if it's a theta spell. I think that's how it's spelled. I think so. Somebody can just verify that on your phones for me. But yeah, the symbol is theta. All right? Give me a minute, guys. My sincerest apologies, my students. I just got an unexpected phone call, but I'm back. All right. So, all right, very good. So that means I can spell Samantha. Thank you very much. So Samantha has confirmed that the spelling of that symbol is theta, theta. And that's just a symbol. Now we have many symbols that we use. I'm going to put them in brackets here. We have alpha, we have rho, we have, I don't remember how to draw them, I know some of them, alpha, I have rho, I have beta, all right? So all of these are basically symbols that we use to represent an unknown angle. So we have theta, we have alpha, we have beta, we have omega. I don't know how to draw omega symbol. I don't remember how to draw it. Right? So majority of the time for mathematics, we normally use alpha and theta. All right? Okay, lovely. All right, so theta is just an angle that will be given to you. So you're sure? Yes, I'm sure. I'm sure them will give it to you. It's either they're going to give it to you or they're going to ask you to find it. But we're not get to the point where we're learning how to find it yet. We're at the point where they're giving it to us. So in this case now, guys, watch the color marker that I'm going to use now. When you get theta, theta will tell me you're not seeing the whiteboard. You need to exit the class and come back in. Is there anyone who else is not seeing the whiteboard? Latisha, if you're not seeing the whiteboard, you have to jump out of the class and come back in. All right, so now pay attention, guys. See theta right here? Do you see the theta right here? That angle tells me where. Why am I using this? Hold on. Let me just use an arrow. All right, here we go. So that angle tells me where my opposite side is. So now, Galia, when you said earlier that opposite to the angle, that's when we're going to use that statement now. So now we can say that theta tells us the opposite side. So theta tells us the opposite side. So that's the opposite. All right? And so that means this side down here is called the adjacent side. I'm sorry, somebody said something? So that side is my adjacent side. Now there's a common misunderstanding. I'm not sure from whose point of view. Is it the teacher that's talking rubbish? Or is the student that's not understanding what the teacher is saying? Or is the teacher not making her or himself clear? There's a common misunderstanding that the opposite side is always the side standing up. and the adjacent side is the one at the bottom. Rubbish, not Nagoso. That doesn't make sense. And it's not that it doesn't make sense. It's just rubbish. All right? So the opposite side is not always the side standing up. The opposite side is just simply the side that is opposite to the angle given to you in the question. We call it the included or the given angle. So the opposite side is the side that is in front of the angle that's given to you based on the yellow arrow. I say once you're able to locate the hypotenuse and the opposite, only one side left, and that's the adjacent. Now, let's look at, so this is called the model triangle. Okay, it's called the model triangle. We're gonna give her some babies. Let's give her some babies. So she go boom, it's gonna get pregnant, it's gonna have another triangle over here. So this triangle is gonna get pregnant. One baby triangle, hold on, wait. One baby triangle over here. She's not satisfied, so she wants another baby triangle. Another baby triangle down here. And then gonna have another triangle again. 3 kids. Another baby triangle over here. Okay, still not enough. All right, let's do one more triangle. Let's go here. Let's do one more baby triangle. She's gonna have 4 kids. There. Lovely. So you see this right here? This model triangle here has 4 kids. All of them look different. The head there top, the head there base, the head there back, the head there corner, all over the place. Notice that the orientation of the shape is different. But what's most important, how we know say on a jacket picnic she have? How we know say on a jacket is because all of them have one what? One box in the corner. All right, I'm trying to keep the class funny, guys, so you guys can understand that trigonometry is actually fun. It's the most intense, but it's the nicest topic. It's nicer than all the other topics that we teach. All right, so look at this now. We know that these kids are hers. We know that these kids are all right angle triangle. Because why? What do you notice about all of these triangles? What is one thing that's common between all of them?
They all have a 90-degree angle.
Excellent. So we know say a fear pitney that, a fear pitney that, a fear pitney that, a fear pitney that. That means if it's your child must have some similarity to you, not true? All right, cool. That means every one of these triangles, if they are your kids, they're supposed to have a hypotenuse. So look at this now. The height for this one is right here. The height for this one is down here. The height for this one is right here. And the height for this one is right here. So notice that the height side or the 8th side, I'll call it the 8th side, just to make learning easier. So the 8th side, why is this H looking like this? Looking like a hashtag. Oh my God. Lovely. So do you notice where the 8th side is? All of the 8th side is what? In front of the what? 90 degree. And just to prove to you now that just in case your teacher is the one that tells you this, or maybe that you think you're here, because me have to defend my teacher them too, But at the same time, some of them have to dash them to the curb. Because sometimes they will tell you foolishness, Because it's how they are taught, So they're going to the system telling you what they are taught. All right? So the 8th side, you notice where the 8 sides are? They're all in front of the 90 degree, in front of the box. Now look at this now. I'm going to put angles all over, different places. Let's get a different color ink here. Let's use blue. Right, lovely. I'm going to place an angle here. I'm going to call it theta. I'm going to place an angle here. I'm going to call it theta. I'm going to place an angle here. I'm going to call it theta. I'm going to place an angle up here. I'm going to call it theta. Notice based on the position where theta is, then my O side will land differently. Look, see, my O side is at the bottom here. My O side is to the left here. My O side is to the right here. And my O side is down here. Do you then understand why we say that the opposite side isn't always the side standing up? Because the opposite side is not the side that's standing up or whatever you guys hear or think you hear or whatever the teacher tell you. The opposite side is the side that is opposite to the angle that is given to you in the question. Respect, Craig. All right, so it look like I want to connect with you now, Craig. Very good. I say once you locate H and you locate O, then guess what happened? Only one side left, and that side has to be your A side. So that's my A side here, my A side here, my A side here, and my A side here. So do you notice how easily I was able to identify my A, my O, and my H? Lovely. That is it. That is what we call the introduction. So now this very simple little triangle here that many of you seems to hate with such a passion, you just never understood the guy. You just never understand him. So now you have to say he's really a harmless little fly. It's a harmless little triangle. All him have, he's just one like a 90-degree angle and 3 little side. And then sometimes he have an angle up in the corner here. Sometimes he have an angle up here. And the angle kind of tell you where the sides are. Pretty much. And that is what we call, well, those are what we call, this is what we call the parts of the right angle triangle. Any questions thus far? No questions? Miss Grayson, you sure you want to stick with the bet? Come. The people them are looking in the chat, you know. You come boss up big bet, you know. You still want to stick? Okay, all right. You're not running. I guarantee you're running, you know. We have a $10,000 bet. Okay. You understanding thus far, though? Understanding thus far? Good. That means I'm winning the bet. Okay, here we go. Now, the next phase of this now is where we're going to introduce So remember now, you know, this is the model triangle, you know. This is the model triangle. So this model triangle is going to encounter a few different partners. All right? She's going to end up being in a relationship with Pythagoras, who is this muscular green mathematician. Then she's going to not like Pythagoras anymore, and she's going to have three little, you know what I'm saying? You know what I'm saying? Yeah, cosine, cosine, and tangent. And then she'll get tired of them and say, you know what? Sick of you, I'm going to go to cosine rule, then sine rule. So we're going to go through those guys. All right? Tonight, based on the time, we don't have a lot of time, I'm just going to quickly introduce to you Pythagoras, and then we're going to pick up from this part next week. Okay? So, again, I'm not going to go into who Pythagoras is. All I can tell you, look him up. Hold on. Sometimes we need to just have like a fun. So, let's go to Google. Oh, you guys are not seeing my screen, right? Uh-oh.
No,
All right.
sir.
Hold on. You're seeing it? No, but all right, hold on. Hold on. All right, stop share. So, let's have a look at Pythagoras. Uh-oh. Sorry. Share my screen. All right, so let's have a look at who is Pythagoras. Because sometimes you teach maths, you know. Sometimes you just make the person see who you are talking about. You're going to see how Pythagoras is a handsome man. Please vote in the comments and let me know if you think Pythagoras is handsome. Do you think he's handsome? Let's find out. Are you guys seeing my screen?
Yes, sir.
Yes,
Yes, sir.
You all see my screen. Let's see who is Pythagoras. Let me know. Ladies, do you like Pythagoras? Please let me know if you like Pythagoras. We're going to look at this guy. This guy. Some love teach online, you know. And online teaching is the best. You get a chance to do a lot of stuff. Pythagoras. Let's look at Pythagoras. Tell me if him look handsome, ladies. Gentlemen, this question is not for you. So keep quiet. There is Pythagoras. Ha ha ha! Look at that lovely beard. Look at that nice hairstyle. Ancient Greek philosopher and polymath. An ancient Ionian Greek philosopher, polymath, and eponymous. Another one man like that. Me blow wow. Huh? Chai! Let's look at his picture. Boss, favorite boss, this man. Look at this man. This man mastered the right angle triangle. See that? Look at that guy. Look at him look good. Nice beard and come from him Greek era there. See that? Ladies, wanna say? Miss Grayson, how him look? Nah, answer me. Nah, answer me. You nah answer me. Oh, you nah answer me. Hey man. See that? Zahina, that is so disrespectful. He's such a handsome gentleman. Tishana is like, guys, come on, man. Don't do that. Style, man, you know. Do like Jamaicans that style me, you know. Style me. Co-Pythagoras, nice and handsome, eh? Oh Lord. I need my whiteboard. Sorry guys. I need the original whiteboard. Mm-hmm. I cannot believe you guys literally disrespected Pythagoras like that. Huh? How could you do that? That is so... You're not very kind. Where's my whiteboard? So now I'll mess up on my whiteboard here. See that? Cannot believe this. Simone has be like, where? You mean where? Such level of disrespect. He's such... Look at that nice beard. Huh? Miss Tasia, you can't help me, can't defend me. Come on, man. Tell him Pythagoras looking handsome.
Of course, you know, me can't talk much tonight. That doesn't fit talk much. Well, you're going well, man. You're going well.
Oh, man. Pythagoras is one nice man. Look on the man beard. Simonia, rub your hands through his beard. Hey. I'm just describing what I saw. That the matter with the funny business in this class, the Simonia. Matter with the funny business. Sure. Huh. All right. So we don't want to have too much fun, you know. Where's my whiteboard, guys? I cannot believe you guys. I need back my original whiteboard. 822, 825. Must be. Oh, here it is. Where's my whiteboard? There we go. So now see Pythagoras, I'm going to bus, right? All the single ladies. So put your hands up. Pythagoras is here. Okay. So what is Pythagoras saying? What is Pythagoras saying? Thank you, Miss Nicolita. You mean him can go on. Give him a chance. All right. So what is Pythagoras saying? I'm going to run through this quite quickly. Pythagoras is saying, right, in a nutshell, here's what he's saying. He saw this triangle here, and he says that if you square this side, it's 8 squared, and any one of these can be O or A in this case because there's no angle. I'm just going to call this my O, and I'm going to call this my A. All right? But the A can be the O and the O can be the A. It's just that nothing can be the H. The H is just always going to be the H. So what Pythagoras is saying is that if I square the hypotenuse, it's going to be the same as if I square the opposite. It's going to be the same result as if I square the opposite and I square the adjacent. That's what he's saying. So Pythagoras is saying that, okay, if I square the hypotenuse, it's going to be the same as squaring the opposite and adding it to the square of the adjacent. Now, hold up a bit there, because it's a student of mine some must start teaching it this way, and say, so I actually like it this way. How I normally teach it and how they teach it in high school is a bit different. Because in high school, they tell them that c squared is equal to a squared plus b squared. So some of you guys are familiar with this whole c squared, a squared, b squared thing. This same thing. It is the same thing. Lovely. Who is Zoom user? You haven't changed your name. I know who you been about. I don't remember your name.
Sorry, sir. I've been trying to, but it's not working out.
When you're logging in, man, you have to change your name here.
Okay, sir.
All right. So, yeah, so you were looking over this today, right? So some of you guys are familiar with c squared is equal to a squared plus b squared. Cool, no problem. Right? I'm going to use my new student's technique. She said must call it this year. It makes learning easier. I said, all right, then cool. All right, so she said that 8 squared is equal to o squared plus a squared. And why I like this is that later on, I don't have to explain to you what is h o and a, right? In this case, we know say h is representing hypotenuse, o represents opposite, and a represents adjacent. Down here, we have to go then tell us, oh, remember guys, c represents the hypotenuse, a and b represents o and a, right? So we're not going to use that method here, right? So the formula that we're going to be working with, guys, is 8 squared is equal to o squared plus 8 squared, all right? So that's the hypotenuse squared is equal to o squared plus, I know 0 squared, you know what? I don't even trust someone, I do not trust Ono. I do not trust Zahenia. Oh, you know what? Let me write it better. Oh, did I say Zahenia? I'm sorry. Me know you go complain. I joke me and make. O squared, guys. Not 0 squared. O squared. All right, so 8 squared is equal to o squared plus a squared. Let me give you one quick example because, like I said, I spent a lot of time ensuring that you understand the fundamentals so that when we forward next class, we are box through this and box through trig, sine, cosine, and tangent. So quick example before we get out of here. Boom. So here it is. Quick example, guys, because I know you guys are tired like I am. Oh my. What's going on, Mr. Peart? Okay. All right, quick example. So I'm just going to call this side 10 centimeter. I'm going to call this side x centimeter. I'm going to call that side x. I'm going to call this side 4 centimeter. No, let's not make it 4. Let's make it 7 centimeter. And the question says, find x. So I want to know what's the length from here to here. So to do that, we're simply going to use the formula 8 squared is equal to o squared plus a squared. In this case, 8 squared is 10 because we must say the hypotenuse in front of the 90 degree. So that's going to be 10 squared. In this case, it doesn't matter what you want to call O and A. You know the reason why it doesn't matter? Do you know the reason why it doesn't matter which one you want to call O and A? Because even though we know so one side is opposite and one side is adjacent, we're not quite sure which one is opposite or adjacent because there's no angle in the question. So if Miss Stacia want to say, you know what, I'm going to make this O and make that A, and Latisha want to say, you know what, no sir, I don't like it. I want to make this A and make that O. Both ladies are going to get the same answer. All right, so in this case, I'm just going to call the O 7 squared. And then I'm going to leave this as x squared, right? Because A now is the adjacent, so it's x squared. 10 squared is 100. And 7 squared is 49 plus x squared. Remember, you cannot add 49 to x squared, I don't think I have anybody in here who is doing that foolishness. Because we got through the whole 2.5 months out of algebra. So nobody should be making any mistakes such of that magnitude. So now we're going to bring this over here. Remember, we just complete algebra, so we're going to bring this over here. So we're going to get 100 minus 49. That's going to be equal to x squared. So that works out to be 51 is equal to x squared. And then you take the square root of 51, and you get x. So x works out to be a little bit over 7. It's about 7.4. Confirm, please. What's the square root of 51? About 7.4? I think so. Maybe. I don't know. 7.4, 7.3, 7.2? I think it's about 7.3 or 7.2.
7.14.
Oh, so 7.1. All right. So basically, it's like an isosceles triangle, pretty much. So 7.1 centimeter. All right? Lovely. But when we come back next class, right? When we come back, Zahenia, take your hands off my right angle triangle because you do not like Pythagoras. Thank you very much.
Sorry, sir. I was screenshotting me too.
Good. Well, take your hands off Pythagoras.
Sorry.
All right, guys. So in our next class, we will look more in depth at more examples. Remember, this is just an introduction. You'll get some funny looking shapes like this one and like this one. And them shapes that we're going to work on. All right? So in our next class, we look at that, but I don't want to keep you any longer. So if there are no questions, any queries, or anything like that, we will go ahead and pick up next week, Monday. On Wednesday, we're going to wrap up the last part of trigonometry. Have yourselves a productive, peaceful, and prosperous rest of night. Be safe. Bon voyage. Adios.
Thank you. Same to you, sir.
Adios, sir. Thank you.
Sir, before you go, do you
Thank
have
you. Good
any
night.
video with this?
I
Good
do.
night.
Yes, I do. I already have a full video tutorial on Pythagoras theorem, and I also have videos on trig and sine and cosine ratio already.
Sir, can you send it so that
Oh, you want?
it's not
I'll
just
send it to
yes.
you, and then you send it in the group so
All
that
right.
everybody can go ahead of me if you guys want to.
Yes, I would love that.
Okay. All right, guys. Have a good night.